seems like you're in a completely different class, like what happened while I was gone. So this will kind of fill in that I guess the material that you missed, right? So if you missed class, make sure first thing you do is go watch the video before you start emailing me, like what did I miss, because it's all going to be there, okay? All right, let's get started. I need to get in here and get into Canvas. So I'm hoping that all of you are familiar with how to get to Canvas. Logging in through ACES. Yes? Okay. Oh, wrong one. I think it's that one. Yeah. Okay. Let me have your sticks. Make sure hold on. Let me make sure my microphone is on. Yes. Okay. Sticks. Thank you. Sticks, please. So anyone have any idea what these sticks are for? I'm going to call you out randomly during class like this. That sucks. You shouldn't have filled out a stick, right? All right. Any others? Just leave the markers on the table. I'll get those at the end of class. All right, so everyone can get to Canvas? Yep, okay, so go to My Courses, and spring 2019, and we are college algebra. As you can see, I mostly teach calculus, but I'm teaching this class because it fits into my schedule just really nice, so here we go. Has anyone already been here? Who's been here already? Okay, so if you have not been here, you need to make sure you come here. This is where I'm going to have everything for the class. The center of the homepage has the class packet, which is what you're supposed to buy at the bookstore. Did anyone buy that? How much was it? $12? Yeah, so you're going to have to break the bank, I guess. $12. Where is it? Do you have it also? Is that the binder? You bought it at the bookstore? Can I look at it real quick? There's something with the numbering that I was a little bit concerned about. See if it matches what, okay, so this matches what I have. Very good. Thank you. All right, so buy that packet, or you can actually just download it here and print it at home, but it's 120 pages, so if you don't want to print it out, go spend $12, and it's at the bookstore. All right, let's go through the syllabus. I know you can all read, and we have to go through all this, but there's some important things here. First of all, my information. So if you want to ever come by my office and get help, this is where you go. Oh yeah, my name is Robert D. Giovanni. Come on in. Are you math 13, 14? I can tell you right now if you're here. What's your last name? Yep, you're here. So, my name is Robert D. Giovanni. I'm a full-time instructor here, so sometimes you get instructors that are part-time, so they're only here a little bit during the week. I'm here all week, so if you ever need to come by and get help from me, my office hours are listed here. Today, Monday, Wednesday, I don't have a whole lot of office hours. Directly after this class, I'm in my office from 11 to 12:45. Other than that, it's Tuesday, Thursday that I'm really in my office, 9:30 to 12:45. And these are walk-in times. You can just come on in, and if you need help with something, I'm there. All right. Also, I provide you my cell phone number, and that's because I teach a couple online classes, so I provide them my cell phone number, so I may as well provide everybody my cell phone number. The only thing I'll ask is that if you are going to, text me or something, make sure you include your name, what class you're in, at least on that first text. That way I can, always go back and refer to, who's trying to contact me. And then if you have a math question, make sure you take a picture of the problem you're working on, and then a picture of your work, and send it to me through a text. And then I can edit it on my phone with I have a little stylus. I can write on the pictures and stuff. And I can usually find your mistakes. Just know that that's there for you, all right? So What else here? Office hours, materials. I already said you have to go get the packet or download it and print it out. And then you also have to buy a calculator. It's actually required that you get this calculator. And it's the TI-30XS. Yes?
When I went to the store, they had one called the TI-30X2S. Is that?
Yeah, that should work. Yeah, that should work. Yeah. I'm going to say yeah, even though I don't know. Because it's close enough.
It says it has the same functions
Yeah.
pretty much as the other
How much was it? $12. Okay. Yeah, so I mean, the packet and the calculator together, you're still under 30 bucks. I mean, I think that that's pretty good for any college level math course. So get that. And the reason why is because I'm going to be using that calculator during class to do things. And if we're all doing the same keystrokes, it makes it a lot easier than if we have 20 different calculators and I'm trying to show you how to use your calculator, right? So this is just for consistency. We're good? Let's say that I'll expect that you have all these materials by next week. So on Monday? Yeah? Okay. Description of the course. Objectives of the course. Let me just break this down without reading through all this. This should be the last math class that you need. All right? So we need to establish this right now, day one. If you are going into any sort of STEM major, and they don't have it on, well, they kind of have, yes, they do have this on the wall here. There's these math paths, and you need to make sure that this class feeds into your major. Right, so if down the road, if you're undecided right now, you don't know what you want to do, and you decide later that you want to do medical, let's say doctor or something like that. Let's say you want to do that. This class is not going to be okay. You're going to have to go back and take a different math class. This class was designed to break up college algebra into two groups. The group that needs more math and the group that doesn't need more math. And it's just to help students achieve their goal of getting through college, because a lot of students were dropping out because they couldn't get through the college algebra. So this is kind of like your watered down version of college algebra, all right? I mean, that's what it is. And so I'm just saying, I don't want you to spend an entire semester here and then realize you have to go back and do the other college algebra. So if you have any questions about whether or not you are in the right class, we need to address that immediately after class today. All right, I can't do it right now, obviously. Is that clear? But it's on you to kind of approach me, and then I will make sure that you're in the right place. All right? Are there any engineering majors here? Should not be a single engineering major in here. Okay. All right. Anybody feel right now already that you don't belong here? No? No one's on the fence about it? All right. Okay. So we're going to have certain goals, but really at the end of the day, I really think this class is achievable, and it makes getting the college degree achievable for most people. All right, but it depends on the degree. So I'm not going to sit in here like I would in a calculus class and make sure the people who are going to be building bridges for me later need to know how to do math, right? No one in here is going to be building a bridge or a plane. So I think we can be a little more chilled out about it. All right. So for me, I look at this class more about effort and your ability to mature and learn. Right. That's more what this is about, like taking a college class seriously. All right, so let's move on to the grades. Standard grading scale for your A, B, C, D, and F. Those are my only options for your grades at the end. I have to choose from those. And the way it breaks down is we will have homework and quizzes. So I expect that you do the homework, okay, but I'm not going to collect it, all right, because this is college, and I'm not going to babysit you and make sure you're doing all your homework. In fact, I'm going to provide you the answers to all the homework. So it's on you to actually practice the homework, check your answers, make sure everything works out, come into class, ask me questions if you have it. But I will give you quizzes that will be based on homework. So you might walk into class and I might say, all right, we're going to do a group quiz, and I hand out something and everyone works together. I might say, okay, everyone take everything off your desk. Here's a quiz, you do it individually. I might say, hey, I want to see your homework from last time, and walk around and check your homework and take that as a quiz grade. So just do your homework, bring it to class with you, and you shouldn't have any issues, all right? Then we're going to have 4 exams worth 15% each, and then a final exam, which is somewhat comprehensive. That means it will encompass a lot of the ideas. So I'll just kind of pick my favorite ideas from here, favorite things, and put them into a final. But we'll have some sort of review that will kind of get you ready for that, all right? There are no makeup exams, okay? There's no retakes, there's no makeups, there's no test corrections. You know, this is, again, part of getting you prepared for the college environment. When you go in to take an exam in college, you must be prepared for that exam that day. Not later. You don't get to look at the exam, then go back and then redo it. None of that happens here, all right? You have to be prepared. So I will give you some sort of guidance as to what to expect on each exam, but it's up to you to study correctly and be prepared, all right? So we'll see how the first one goes, go from there. Questions at this point? Attendance, this standard attendance policy for the college, you get 4 absences, no questions asked. If you don't show up, just mark it down. You're not here, fine. You get 4 of them. After that, your grade actually becomes, your grade is determined by what the instructor wants to do. So on that 5th absence, an instructor can be like, well, I'm going to drop you from the class. Or they may say, nope, sorry, you're going to fail the class and not even care about your grades. In other words, just don't miss more than 4 times, because then it becomes, it's not in your hands anymore, all right? It's in the instructor's hands. Also, do not assume that you will be dropped from a class if you stop showing up. This is a lesson I learned the hard way in college. There was, I took my pre-calculus in college, my first semester, and sat there, and the instructor was like, there's 250 of you here, because there's a big auditorium. And she said, there's 250 of you here. And she said, I expect to see about 25 of you here for the final. And of those 25, I expect about 10 to pass. And I was like, well, I don't see a reason why I should come back. I don't think I'm going to be in the 10 out of 250 here, right? So I just didn't go back. But I never dropped the class. And then I was shocked when I had an F. It's like, I was only there for the first day. Well, it's on me, okay? It's on me. So just like that, it's on you. If you don't want to be here, if you stop showing up, go drop, because I won't drop you. I'll just give you an F at the end. All right? Okay. Now, blah, 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 blah. Tutoring, okay, so just be aware that there is free tutoring right here on the 3rd floor, right down the hallway. Okay, free, you go in, they've got hours posted on the doors. You can go in there and get help, all right? There's 2 tutoring centers. They do different things. You can just go visit them and talk to them if you need to. All right, SOBI. So when I first started teaching, which was a long time ago, I used to tell my class, you know, first day of class, I said, look, let's see what we would do if there was like an active shooter, like someone in the hallway, like, you know, shooting up the school or something. Like, what would we do, right? I used to say this like way back when, and my students were like, what? He's crazy, right? Now it's like, okay, yeah, we should probably think about this, right? So we want to make sure that we know where our exit points are, and I haven't been in this room this semester. I don't remember if this one does. Oh, geez, that's bright. Okay, so both of these windows are exit points. There's an awning right there. It's probably about 6 foot. And then off the awning, you could run off the awning and jump into the grass or something. Right, so that is a survivable exit through that window. We'd have to break the window, but that's a way out, all right? And that's, of course, if we couldn't go out that door, that would be choice number 1, right? But if we can't go out that door, this side of the room will hold the door, right? While this side of the room exits. No. So, hey, what's up?
Oh, I just want to talk to the students
About the tutoring labs? I had a feeling this was going to happen, so there you go. Perfect.
Oh, hi. I'm here to talk to you about the tutoring labs here. This must be a...
13, 14. Yeah.
Oh, okay.
Yep.
So we have 2 tutoring labs here, one in 308, one in 316. And in 316, you just come in and sit down and raise your hand and somebody will help you. There's no limit. You can come in any day, any time. There's no limit. And in 308, you come in and have a 30-minute session with this one-on-one session with a tutor. But you are limited to only 5 sessions per semester.
Yeah.
The labs are open from Monday to Friday, 8 to 9.
8 a.m. to 9 p.m. That's some pretty good hours, I think.
Yeah, 8 a.m. to 9 p.m. Well, on Friday it closes a bit. They close a bit early.
Yeah. Okay. Hi, Julie. You talk to me? Oh. Hold on, I'm being summoned. What's up? You. Okay, so I was just told, just to remind everyone, is anybody here a business major? Business? You sure? Okay, then you're not to be here. Do you want to go? Okay, go to room 308, and there's a guy there. His name is Jesse, and he will help you find the right place. Okay? Anyone else? Anybody else want to change to business just so you can get out of here? No? All right. It was fun. It was fun, wasn't it? Okay, so how we can get out of here if someone starts shooting up the school, right? That's where we were? So, yeah, no. Oh, what? Oh, you didn't answer? You didn't say you were a business? All right. Room 308, right down here. So I just don't want us, there's this saying, I don't know if you've ever heard it, and this is probably wrong, but it's something like, luck is preparation meets opportunity. Have you all ever heard something like that before? Luck is preparation meets opportunity. So I just would hate, and I think about this when I'm with my family too. It's like I don't want to be like huddled up in the fetal position at the movie theater because I didn't realize there was an exit right there. You know what I'm saying? Like, so we just want to be prepared. You want to just know what you would do in certain situations. So these windows are our way out. Isn't 2019 great? Okay, behavior policy. So I actually do have this. I think you're not going to like. I don't want you using your phones during class. So for an hour and 15 minutes, I expect that you are going to disconnect from your electronic life and come in here and participate. And if you don't do that, if you're texting, using your phone, sleeping, then I'll take 10 points off your exam. The next exam. And I'll do that every single time you do it. I'll also ask you to leave the class and I'll count you absent that day. So remember, you only get 4 of them. So it's pretty severe penalties. And you know, that's just because I don't know, maybe I'm old school, but I know you're paying for the class and maybe you feel like you have the right to do it, but I still have the ability to make the rules. Until they take that away from me, there's my rule, all right? Anyone want to leave now? Go get into another 13, 14? Sure? Okay. All right, we have a schedule. I'll show you. This is the schedule in the syllabus, but there's a better one that you can print out right here. And this kind of shows you day by day what we're going to do. All right, and this is tentative. It might change. It depends. But like today, introduction, and we're going to talk about fractions. And then here's your homework for that for tonight. All right, out of that packet. And then we just keep proceeding. And then look, we have a test pretty soon, right? Test 1. And then we have test 2 is right before spring break. Test 3. And then test 4 is right before the final. Well, a couple of days before the final. So our final's here. And then our test 4 is there. So that's the plan. Okay, that's what the plan is to get through all that material. Okay? All right. Whoa. What else here? Oh, so also the videos that I'm recording right here, if you click on that, then that'll take you to my YouTube channel, and there's no videos there yet because obviously I'm making the video right now. So they'll start to appear here, and I'll just list them, 13, 14, day 1, day 2, day 3, day 4. And then I have my old lectures. I think I'm going to take those out. There's no need to look at my old lectures. And then files. Oh, homework solutions. What's this? Oh, the packet has solutions. That's right. So there you go. If you click on that, that'll give you the answers to your homework problems. All right. Questions? How do we communicate? You have an inbox over here in Canvas right there. That is the official way to communicate with me. You can call me and text me. That's fine, but that's never official. All right? It's always got to be, if I'm not going to be at class or something like that, you want to let me know something, I'm going to miss the exam because I've got a family crisis, send it through here, all right? And that way it's documented. Or if I tell you, guess what I'm saying is if you text me and I tell you something, that doesn't count. It has to be through here, all right? And that's just to cover your butt and my butt, like if we're arguing about something, we can both go back to this, all right? All right, I think I'm pretty much done, unless anyone has any questions. No, y'all are ready to get into do some math? You look thrilled. I want to show you on the schedule. I realized I looked at the packet over there a second ago because there's a mistake, not a mistake in the packet, but there's something wrong with the packet. So I want you all to look at this. Here's the packet. And so the way the packet works is we're going to start out in this section, multiplying and dividing fractions, adding and subtracting fractions. We're going to go through these things. This is what I'm going to do in class with you. And then you have your homework, which is going to show up. You'll see here it says homework, right? And notice this. It has, no, so you are in the right class.
Yeah.
Okay. Okay. So the homework, see where it says part A, right? Okay, so I want to go and bring up that schedule. So your homework for this section, well, that's not the right one. Oops, that's my calculus one. Where'd it go? So can you all see here how it says page 7 and 8, A, and then 1 through A15? Does that make sense that's A1 through 15, right? So this one is not for homework. All right, so here's where things get messed up. Watch. On the schedule, it says now do B1 through B9, right? Well, go back to the packet. Here's B, and look where it starts. 17, right? That should be B1, then B2, then B3. Does that make sense? So they messed up. I don't even know who it is, but somebody messed up. And so they're talking about these 9 problems are for homework. And I believe it's going to be like that throughout the whole packet. So just be sure. What I would do is just, if it calls for you to do a homework, part A, just try them all. It's not going to hurt. All right, let's get started. Got my sticks now. So the way I'll do this is if I call you, you'll go into the been called pile, and then I won't call on you again until I've gone through everybody. All right, so you're only going to get called on once. And look, there's no shame in here, all right? I mean, you're here to learn, so if you don't know, I'm going to try and help you. So don't be all embarrassed or freaked out. No one's going to leave here and be like, oh man, this guy in my class. I mean, I don't think it's that important to anyone, right? Right, Colby? Where's Colby? Right, Colby?
Yes, sir.
That's right. See, you're already off the hook. Look at that. That's bullshit. That he's out already? Should I ask him a question? So they're saying that I should make you do more over here. That's what these guys want me to do. Yeah. All right. Okay, so we're going to start with multiplying and dividing fractions. Now, this material that we're covering right now is all considered to be review material, meaning that this is something you should all be familiar with. Now, it's going to be like that until we get to, I forget here. Yeah, I think until after test 1, pretty much. So, I mean, it's only 1, 2, 3, 4 days of review. It's 4 days of review. So all these topics are things that we expect that you have seen, all right? But you never know how you learned it and how, if it's stuck or not. So we will proceed through it as if you've had a very good break, all right? And you don't remember everything. So how do we multiply? How do we multiply and divide fractions? So if I give you 2 fractions, how do you multiply them? Go ahead. Across, right? So if I were to try and come up with some general formula for multiplying fractions, I'm just going to put here multiply. I'm going to abbreviate fractions. Then if I have a fraction a over b and I multiply it times another fraction c over d, then all you have to do is multiply straight across. So you do a times c over b times d. And that's it. I mean, if you like formulas, that's the formula. So for this first one, Samantha, I'm putting you on the spot, Samantha. What would you get here, Samantha? 12 on top. Okay, so yeah, maybe you need a calculator, right? So you have one or no? You can use your phone today if you want. I won't penalize you for having your phone out today. Right, but we're going to do, pardon? 144? Are we all good with that? Okay, so now the question becomes, is that an acceptable answer? Well, I mean, it is correct, but it's not what we call reduced. And reduced means we want to see if there's any number that goes into both 12 and 144. So can you think of a number that goes into both 12 and 144? 12 itself, right? So you basically say 12 goes into 12 one time, and 12 goes into here what? 12 times, so you get 1/12. Right? Now that's fully reduced. And that's what I would expect is for you to perform the operation, reduce the fraction. Now does anybody have a different way we could have done that and still got 1/12 without having to do any reducing of a fraction? Okay, so before we start the multiplication over here, we could have looked at this. This is, I know what you're doing. You're saying 4 and 16, right? Like that, and then you could do the 3 and the 9, right? So essentially, if I kind of try and make this visually easier to see, I guess, is what you're doing. What you're really doing is you're saying, I'm going to break the 9 up into 3 times 3. I'm going to break the 16 up into 4 times 4. Right? And then you can cancel one of these 4s and you can cancel one of those 3s, like that. Do you all agree with that? And if you do that, then what would be left on top? If you canceled everything out, which we have, what would still be there? A 1. And then on the bottom, you'd have 3 and a 4 being multiplied, and that would give you 12. So you could have done it that way also. All right, there's multiple ways, I guess, is what I'm getting at on how you could multiply those 2 fractions and reduce them. I like this way because I don't have to do that step of thinking of a number. But I think I would do it the same way. I would say 4 goes into 4 once, 4 goes into 16 4 times, 3 goes into 3 once, 3 goes into 3 9 times, something like that. So again, there's multiple ways to get to the answer here. All right, good. That was Samantha, right? Okay. All right, so we'll go with Matthew Griffin. Where's Matthew Griffin? 3. So just talk with me through number 3. How would you like to approach that? Do you want to multiply those straight across right now? Or do you want to try and like break it down first? You know what I'm saying? Do we want to multiply these across, or do we want to try and figure out there's something canceling? Okay. Okay, so you want to try that? Do you have a calculator? Okay, so let's do it. 21 times 16. Okay, and then 24 times 28. 672. Do you see kind of, yeah, you see, Matthew, right? Okay, so you see how doing it that way, yes, that is correct. You've done it right, but man, I mean, like, do we want to mess with those numbers? Like, those are big numbers. It's going to take us a while to try and figure out what goes into both of those. So what's that?
You just divide the 672 by the top 336.
If it happens to work. In this case, it does. We kind of get lucky, right? But if in general, that wouldn't necessarily work. So maybe in the beginning. So let's look at all the numbers and see if the top numbers and the bottom numbers have any common factors. So how about 21? I'm still with Matthew here. Can you think of the numbers that go into 21? 3 and 7, right? 3 and 7. So how about on the bottom? Do 3 or 7 go into any of those? 28? What goes into 28? 7 does, right? So these two numbers right here, 7 goes into both of those. So I could say 7 goes into 21, how many times? 3 times. And 7 goes into 28 4 times, right? Now, you still have a 16 and a 24. Can you think of two numbers, or a number that goes into both of those? 8, yeah, 2, 4, right? There's a bunch. So you want to try and get the biggest one. 8 goes into this twice, and 8 goes into here 3 times. So now what you have, yeah, so if you stopped here, I mean, because you could actually cancel the 3's, but let's just act like I don't see that. If I multiply across now, forget this, I actually get, what, 6 over 12? And that's easier to reduce, don't you think? You can just look at that and say, 6 goes into both of those, right? So this would become 1/2. Okay, so I think that's one of those ways where you don't want to ever get yourself like locked into one method where you're just like, if I ever multiplying fractions, I'm just going to be a robot and multiply straight across. I'm not saying that's what you're doing, but now you can see the value of approaching it a different way here, right? Okay, moving on. All right, so let's see who's up here. We're going to do some division now. And we're going to see if Cameron, where's Cameron? We're going to see if Cameron knows how we do fraction division, like number 2. 7 and 9. Okay, so you're saying I'm multiplying 7 times 9? You're right. You're right. This is right. Okay, but let's write it down, like what's happening here. When you divide fractions, here's the way it works. If I give you a fraction, a over b, and I divide it by c over d, so instead of multiplication, we have division, what you do is you leave a over b alone, but you multiply, you change division to multiplication, and you flip this fraction over. So when you flip a fraction over, it's called the reciprocal of the fraction. So I'm going to flip that, and that becomes d on top and c on the bottom. So this is fraction divided by a fraction is equivalent to the fraction multiplied by the reciprocal of the second fraction. So then you go straight across now. So this problem, Cameron, you said would become?
7 times 9.
Okay, so that's because we're changing division to multiplication, we're flipping this fraction over, and then going straight across. So those numbers aren't that big, right? So we can just go across and see what happens. 7 times 9, 63, and then 8 times 2, 16. Is that reduced? Is there anything that goes into both of those? How could you convince yourself that there's nothing that goes into both of those? Well, to do it, you actually have to do something that's a little tedious. But I'm going to do it and just see if it looks familiar to you. I'm going to take the number 63, and I'm going to do what's called its prime factorization tree. I'm going to break it down. So 63, we got that from multiplying 7 times 9, right? And then you can't break 7 down, right? Because 7 is prime number. But 9 can be broken down to 3 times 3, right? So if you take 7 times 3 times 3, that's how you get 63. So you can look at the top of this as actually being 7 times 3 times 3. Do you all understand? Now you do the same thing with 16. 16 is really 4 times 4, right? But 4 is 2 times 2, and this 4 is 2 times 2. So another way to get 16 would be to multiply 2 times 2 times 2 times 2. So this is 2 times 2 times 2 times 2. Every number up there is prime, right? 7, 3, and 2, they're all prime numbers. Nothing cancels, does it? You don't have any 7s on the bottom. You don't have any 3s on the bottom. You don't have any 2s on the top. Nothing will cancel. That means this was completely reduced. There's nothing that goes into both. All right? So if you're not sure, you can either use your calculator and keep trying numbers, or you can just do a prime factorization of each one and make sure there's nothing in common. Does that make sense? Okay. Questions? Yes? Oh, or a what? A mixed number. Leave it like this. Yeah, that's going to be a little problematic. Either way. I'll say that way. Either way. What do you mean by mixed number, just so we can all be on the same page? So how do you turn this into a mixed number? How many times 16? So you're actually going to do something like this. Like you divide 63 by 16, which it goes in how many times? 3 times, and then you multiply that times 3. What's that times 3? 48. You put that under here, subtract, and you have a remainder here, 15. So you have remainder. I'm going to put R15. I know that's old school, but that's what we have, right? So this would turn into 3, and then the remainder 15 over the 16 here. This is called a mixed number. Okay? This is called an improper fraction. So personally, again, this is because I teach mostly calculus. In calculus, we don't mess with this. This is like, I don't know, how can I explain it? Do you remember when you were like very young and they taught you multiplication, they used that symbol? That was like the old school multiplication symbol, and then they started doing dots. Okay, well, this is like the old, this is like if you're mixed numbers, is you use those when you're still like at this level. In calculus, we use that almost exclusively. We never mess with mixed numbers. So I prefer this, but this is correct. And if you give me this as an answer, I'll be happy. Okay? All right. Next. We got that. Yeah. Well, let's see who's going to be the brave soul. Oops, you got lucky. Valeria? Did I say that right? Okay. You're up. I'm looking at number 4. So, what are you thinking there, number 4? Okay. Okay, great. Now, this is the correct first step. There is a dangerous step that you could have done that would have been incorrect, and that is, you know how back here on this one we started like canceling things out? If you're right here and you say to yourself, oh, you know, like 2 goes into 4 and 2 goes into 18 9 times. You see that? That's incorrect. You can't do any canceling until after you've done the flipping, all right? Don't do it before. So here at this point, we can start doing any sort of simplification. Do you want to continue? Okay.
And so for 90 to 18.
Okay, good. You're going to replace the 9 with the 3 would work, but there's a bigger number that goes into both. 9. So 1 and then 2, right? Can we keep going? Skylar? Where's Skylar? Skylar, can we keep going on this?
We can do that. Oh, wait, no. 4 doesn't go into 42 even.
4 doesn't. Does anything else, though, go into both? 2, right? So you could go 2 goes into 4 twice, and 2 goes into this 21 times.
So 2 over 1 and then 2 over 2.
Yep, and we can now multiply that, right? I'll write it down. This is really where we are. And then go across. So 4 over 21. Bam, there we go.
Quizzes, I know you said both answers, mixed numbers, or improper fraction. Are you going to be like looking for anyone specific?
Nope. Nope. All right. Leslie. Hi, Leslie. You get number 5. So what would you like me to do on that one? Kind of forces you to pay attention when I'm calling on you, huh? A little bit?
Divide across.
Okay. How do you mean?
Multiply.
Okay, multiply across. Okay. So you don't want to mess with any of the, like trying to figure out, it's okay if you don't, but, oh, okay. So I'm going to go straight across. So what do I get?
4
Okay,
over 40.
40. Okay. Now, the question is whether or not that's reduced. So is there a number that goes into both of those? Four, right? Okay, so 4 goes into 4 one time, and 4 goes into 40 10 times. So you get 1/10. All right, so we'll see about this one. Pay? Am I saying that right? Is it pay? Okay. You get number 6. So I haven't talked about how to do number 6. So maybe you can help us out. Do you want to come up here? You'll be on camera. No. 30 over 9? Wait, did you say 13 over 9? Okay, so I think what you're doing is you're changing these, right? You're switching those. So pay is taking a mixed number and changing it back into an improper fraction. So we showed a second ago how to go from an improper fraction to a mixed number, but how do you go the other way? So if you take 1 4/9, the way to get it back to an improper fraction is to multiply 1 times 9, and then what? So 1 times 9, and then add the 4, right? You've seen that before? 1 times 9, add 4, so that would give you what, 13 over 9. So mixed number, improper fraction. So you did that first, right, for both of them. So let's get this one here. Let's switch that one over. 2 1/4 equals what? 9/4. Okay, so I'm going to rewrite the problem then. This right here is 13 over 9 divided by, and then this one was 9 over 4. Okay, then what did you do? Multiply 4 over 9. There we go. So division becomes flipping the second one, multiplication. And did you do anything here? Did you just go straight across, multiply straight across? No?
The final answer is 52 over
52 over 81, yeah. So if you multiply 13 times 4, you get 52. 9 times 9, you get 81, right? And nothing cancels. Nothing, this does not reduce. How do I know nothing reduces? I mean, look at this. These two, nothing can cancel in here, right? There's no number that goes into both of these, 4 and 9 or 13 and 9. So I'm fully reduced at this point. All right. That's it for for multiplication and division. Now, when you're first taught fractions and arithmetic with fractions, you're taught multiplication and division first. And then you're taught addition and subtraction. Why does addition and subtraction come after? Yeah, because it's harder, right? It's more complicated. It's harder to add and subtract fractions than it is to multiply and divide. You can't just go straight across. You have to have a common denominator to do it. So, for example, what I'm saying is this. If I have a fraction with a denominator plus another fraction with the same denominator, so if I have the same denominators in two fractions, I can add them across without doing any more work. All you have to do is add the two numerators tops together, right? And then what do you do with the denominator? Keep it the same. All right, so for example, if I had 3/5 plus 7/5, then because they both have a 5, I would just get, 10/5? So 3 plus 7 is 10, 10 over 5, and that's just 2, isn't it? 10 divided by 5 is 2. So if we have the same denominators, it's pretty straightforward. But as you can see for these problems, none of them have the same denominators. So how do we add fractions when they do not have the same denominators? We have to get them to have the same denominator, right? That's what makes this tricky. So let's start with this first one. And again, there's more than one way to do this, all right? So let's look at this problem and let's recognize it's addition, right? And that means these two have to be the same, but they're not. So what we need to do now is come up with something. We call it, what do we call it? The least common denominator. All right, so that means we need to come up with a number that is a multiple of both 8 and 5, but the smallest one we can find. And 40, right? 40 is a multiple of both 8 and 5. So that means I can turn this into a 40 and that into a 40. So how do we do it? How do we turn those into 40s? What do we have to do? Yeah, we have to take this 8 and multiply it times 5, right? And we have to take that 5 and multiply it by 8. But to do that, we have this rule that says whatever we do to the denominator, we have to do to the numerator. So if I'm going to multiply this 8 by 5, I also have to multiply the 1 by 5. So notice I introduced a multiplication next to this. And then over here, same thing, right? Multiply by, what? 8 on the bottom and 8 on the top. Now, why is it that this is okay? Why is multiplying by this not changing the problem? That's right. 5 over 5 is the same number, right? What's 5 divided by 5? 1. So you're really multiplying by 1, right? And anything times 1 is still the same number, right? So even though it looks different, it's the same numbers. Okay, so now we do this multiplication. We do this multiplication and we do this multiplication separately, and we do that the way we did up there. We just multiply straight across. Okay, so what would this first one become? 5 over 40. And then this one would become 16 over 40. And now you have the same denominators, right? Yeah, so don't reduce now, because if you reduce, you're back here, right? And then you just gone in a circle. You want to keep the denominators the same, then add them. So now when I add, it's the 5 plus the 16, right? That's your 21 over 40. And that will not reduce. That's done. Okay, does that kind of look familiar? Any questions? Squinting? You're okay? All right. I'd like to show you a different method, just because later on I might use it, and I don't want you to be like, what the hell is he doing? All right, so this is a shortcut, but the problem with this shortcut is that it's kind of like, remember the problem we did, Matthew, where you did it straight across and the numbers got real big? This can happen here. We can get really big numbers, but it's super quick, all right? Yeah, it's like a cross multiply. What you do here is you multiply 5 times 1, multiply, you get 5. Then you use this symbol, plus. Then you do 8 times 2, which is 16. And then you put over, and now what you do is you multiply these two together. And that 8 times 5 is 40. And then you get the same answer, don't you? So it's almost like a cross multiply. I don't want to say that, but you're multiplying this denominator to this numerator, this denominator to that numerator. You're adding in between, and you're dividing by 40, which is these two multiplied. And that will work for every fraction, anytime you want to add two fractions. The problem, again, is the numbers can get big. And this might need to be reduced if you do it this way. All right, let's move on. How are we doing on time? I'll leave that there for a second. Yeah. All right. Savannah. Where's Savannah? Hi, Savannah. Number 8. So we have subtraction this time, don't we? So how are you going to handle the subtraction, Savannah? Or do you want to talk about subtraction yet? Or do you want to do something else first? Or you don't remember? Okay, so right now you can't subtract these because they don't have the same denominator. But even more than that, this is a mixed number. So how about we convert this mixed number to an improper fraction first? So we would play that little game. And what does that become? 38 over 5? Is that okay, Savannah? You're okay with converting that? Okay, so now this problem now becomes 38 over 5 minus a half. So Savannah, we don't have the same denominator, do we? So can you at least help in determining what we could use as a common denominator? 10? Okay, so that means you're going to have to multiply the top and bottom of this fraction by what? 2. 2 on top, 2 on bottom, and then over here, 5 top and bottom? Okay. Yes, I think these numbers might get a little bit messy, but what's 2 times 38? 76, right? 76 over 10, and then now minus, because you had subtraction, 5 over 10. And then we subtract fractions the same way that we did when we added them. If they have the same denominator, you go 76 minus 5, which would leave you with 71, and then over 10. And then just box it up. So if you're taking, let's say you're taking a test, all right, and you get to an answer, and you get here, and let's say it reduces, but you don't reduce it. I'm not going to count it completely wrong. You know? Like maybe you'll get like 9 out of 10 points or 8 out of 10 points for not reducing it. You'll get a lot of credit for it, you just not full credit. All right? Any questions on that? Okay. Could this have worked doing it with this shortcut? Would it have worked if we would have started right here and just done that little shortcut? What would have happened? What's that? 76 minus here to here. I don't know why I wrote 5 over these two multiplied 10. And that's exactly what we have, isn't it? Okay. Let's try the shortcut on number 9. And actually, who's going to do it? Tatiana? Where's that? Okay, Tatiana. Are you okay doing the shortcut on this one?
Yep.
Okay, so what would we get here?
I'd say that we multiply like 9 over 9 to 1 6 and 6 is 6 over like 5 and 9.
Okay, hold on. So you want to get a common denominator. Is that what you want to do? Okay, that's fine. So you said 6 over 6 here and 9 over 9 here. Okay, I'm okay with that. So you want to keep going? Okay, so what would this get you if you multiply those together? Mm-hmm. And then I'll have a minus, right? Okay, and then 9 over 54.
I'd say like 21 over 54.
21 over 54. Everyone agree? Okay. All right. Good. Does that reduce? So I'm going to show you real quick how I would, I mean, seriously, this is the way I would do it if I'm trying to figure out if this is reducing. I know the top is 7 times 3. Those are both prime. I know 54 is 9 times 6, right? And I know that 6 is 2 times 3. Right?
Yep.
And those 3's cancel, don't they? I did that fast. Did I do that too fast? No? So really this reduces to be what? 7 over 18. That may not have been that obvious to everyone, that 3 went into both of those. Right? Okay, but it does. So it reduces to be 7 over 18. Now, let's do the shortcut way. Leah? Leah?
Yeah.
Leah, okay. Do you know what I mean by shortcut way? That little crossy thing? Are you okay doing it on this one?
Yeah, I just think that it's just way more work than it needs to be.
Okay, so you don't like this cross way. Okay, good.
I would make the denominator 18 from the beginning.
Oh, you would have got another common denominator of 18, which is completely fine. Yeah. So again, since this is a review topic, I'm kind of going to let you do what you want to do, whatever you're comfortable with. But will you just, for the sake of demonstration, do the crossway here? So what would we get here? 30. And then minus, right? Because this minus, and then what? 9 over 54, right? And that would have given us back to where we were before, 21 over 54, but that would have had to have been reduced. Okay, I think we're good. Y'all feel like we're good? All right. I think we have some word problems now. And word problems are probably the ones that cause everyone the most grief. But they're probably the ones that are the most important. All right. We talk a lot about this. I talk a lot about this with a lot of people that, outside of work, about, why is it that you need to go to school and get a degree? Like, why are people here getting a higher education? Right? Like, what's the point? Like, are you ever going to be sitting there adding fractions ever? You're probably going to use a calculator, So what this really becomes, to me at least, about is problem solving. Whether or not you can become a critical thinker. And word problems kind of force you to become critical thinkers. I equate it to this. Let's say you get hired by some company, like right now, today, some company hires you, and they take you to the copy machine to show you how to work the copy machine, right? And they show you the steps, and you can't retain that information. Like the next day you come in, you need them to show you again. And then the next day you're starting to get it, but it takes them a week to teach you how to use the copying machine. That's probably because your brain has not been trained to process, put things in order. You know what I'm saying? Does that make sense? To become a thinker, a problem solver. And that's what this is really about. The whole college experience, to me, is about producing a person who can come out into the real world and they are teachable, right? That someone can learn. Even if they don't like what they're learning, they can learn it, all right? That's kind of what it is to me. So word problems is where we can get tested on that.